Hello everyone, thank you for joining me. In this video we are going to plot a signal in frequency domain. So as if you followed me for the previous video, I use a cat.wave and plot the time domain of the signal. In this video I'm going to use the same audio signal. Let me paste the code for the plotting of the time domain, and let me run it, and then you see we have a nice time domain signal here. The time axis is in second, and this is the amplitude. And so what we do today is converting this signal into frequency and plot it. All right, so let's begin. So I start off with my variable, and so the variable that I'm using is same x, but it's a capital letter of x, which is normally people use capital representing the frequency domain of the signal. And I'm using FFT. FFT is it's a fast Fourier transform. It's an algorithm built in MATLAB. So I'm using that one. All right, and I have to convert it to absolute value of x. All right, so now I need to calculate the magnitude. To proper scale the magnitude, you have to use x divided by n divided by 2, and then so at this point our magnitude is scaled properly, but the only issue that I see is let me grab the pen. Yeah, so basically what is so when we use a frequency, when we convert a time domain in frequency using FFT, basically what is creating, if let's say this is our frequency, is creating exactly the same thing on the negative side, is exactly mirrored. Or if you have let's say if your frequency domain is look like this, there is another same format in the negative side. So in the next line of code, what I'm doing, I'm getting rid of the negative side. We call it single side frequency domain, which is from here to the end of our signal. So let me clear everything. All right, so now I do x magnitude equals to x mag 1 to n divided by 2, which is grabbing the positive side. All right, so now we need the frequency axis. So to have the frequency axis, I create a f variable equal to 0 to n divided by 2 minus 1, and multiply by fs divided by n. So this is how we can scale our frequency in hertz. So now let me subplot 2 1 2 for the plotting the frequency domain in the bottom of the time domain. And now plot uh, f and x magnitude. All right, so now I run it, and yeah, as you see, very nice scaled frequency domain on the bottom. And this is how you can convert a time domain into a into frequency domain. And as you see, the frequency axis and amplitude are nicely and the magnitude is nicely scaled. And if you see, there are three distinct frequency at 732 and 1030 1380 hertz, and another one is around 2.2k hertz. So basically, this is how you convert a time domain into a frequency domain and plot it. But let me replace uh, our signal with a different one. I have a tiger.wave here. Let me write tiger.wave and let me run it, and then you see the difference between two signals. As you see here, for the different signal, we have a little bit more different frequencies in our signal than the previous one, but everything is nicely scaled. And yeah, this is how you can convert a time domain into frequency domain. Thank you for watching. See you in the next video.